All right, so in this video, we're going to be looking at factoring quadratics. So we've already looked at multiplication, adding, and subtracting. Factoring is undoing multiplication. So it's a special type of division, but we don't have a division problem with a quotient. We simply have the undoing of the multiplication based on what was given to us. So we're going to be looking at factoring two different types of quadratics. The first one we're going to be looking at is a trinomial. So when it's in this form here, there are three terms. And then we're also going to be looking at factoring a quadratic binomial. So let's start here with factoring the trinomial. So once again, these are our steps for a trinomial. I'm going to step you through all of these steps over here. You can also pause and read through them. There are many, many different ways out there on how to factor a quadratic, but all the other ways are all shortcuts and tricks that really get you back down to what you're doing here. This is the surefire mathematical way that works every single time, even though it's a little bit more work than some of the shortcuts. So the first thing that we always have to do is we have to multiply our a and our c terms. So we're talking about that. We're talking about the coefficient at the very front and the constant at the back. So for here, when I'm talking about my a term, I'm talking about 3. When I'm talking about my c term, I'm talking about -5. Our end goal is to determine the set of factors of a and c, so the things that multiply to give me a and c and that add to give me my b term. So when I'm talking about b here, I'm talking about -2. Now, some of you guys have been using the X formation to organize this work for you. So I'm going to do that just to kind of help you organize it. So if you've been using this, in the top part of your X, you do your a times c, because that's always the very first thing we do. So here, this is going to be 3 times -15. Sorry, -5, which gives me -15. Down here at the bottom, we're going to put our b term, which is -2. So before I can start factoring, I have to identify those two things. What is my a times c, and what is my b term? Now, once again, my goal is to find out what two factors of a and c, so what two things multiply to give me -15 and add to give me b. This is kind of where the puzzling piece comes in. For 15, honestly, my first thought is 5 and 3. I do know that there's a way to add 5 and 3 to get -2, and that would be -5 and +3. So those are the numbers that go right here, are those two kind of magic numbers, is what I like to call them. But the two numbers that, once again, multiply to give you here, so -5 and 3 is -15, but add to give you this, -5 plus 3 gives me -2. All that we've done so far are these first 3 steps. These two numbers are now going to be really, really critical as I go into my factoring. What you're going to do is you rewrite the b term as the sum of those factors you just found. So instead of having -2x, I'm going to rewrite this as -5x plus 3x. So all I'm doing is I'm taking the -2 and I'm rewriting it. And because it adds -2, -5 plus 3 is -2. This is an equivalent step. People often ask, does it matter which one goes first? It doesn't. Let's put the other ones first just to see. I could do 3x minus 5x. Does not matter. My other two terms stay the same. And now I have an equivalent expression. This guy, all I've done is I've broken the b term up into two different terms, but these two are equivalent. If I were to combine these two like terms, I get to the same spot. Now that I've done this, I can do factoring by grouping, which means what you're going to do is you're going to put parentheses around your first two terms and parentheses around your second two terms, and you're going to determine what is common here and factor that out. So 3x squared and 3x both have a 3x in them, so I'm going to factor that out to the front. 3x squared, if I divide out 3x, I'm left with just x. 3x, if I divide out 3x, well, 3x divided by 3x is 1. I'm going to do the same thing here. I actually like this because I can show you guys something really important. Notice that my front term is negative. In your second parenthesis set, if your front term is ever negative, you have to factor out that negative. So I know I'm immediately factoring out something that's negative. I also notice they both have 5 in common. So negative 5x, I divided out negative 5. That just leaves me with x. Negative 5 divided by negative 5 is positive 1. Now at this step, I know that I've done it correctly if these match. If my parentheses sets match, then I have done this correctly. If my parentheses sets don't match, then I've probably done something wrong in the step above and I need to go back and double check, or it's not factorable. Most of the time for a quadratic, it just means you've done something incorrectly. Now that these two match, I'm ready to actually find my factors. So those parentheses that match is one of my factors. And these two numbers that I pull out combine to make my other factor. And there you have it, factoring a quadratic. We're going to do one more. That's a trinomial. So let's see if we can do this again. So here, 15x squared minus 27x minus 6. Now, some of you guys might be going, whoa, those are some really big numbers. And I chose those on purpose. They are really big, but what you need to do when you see something like this is always check, is there something that we could factor out from the very beginning? I know that each of these are divisible by 3, so I'm going to factor 3 out from the very, very beginning. 15 divided by 3 is 5. 27 divided by 3 is 9, and 6 divided by 3 is 2. So now I like to put a little like star or cloud around this guy. I'm going to leave him here, and I'm just going to work on factoring this quadratic. I'm going to do that x again just to organize. So the top is going to be my a times my c, which is negative 10. The bottom is going to be my b, which is negative 9. So once again, I'm looking for things that multiply to give me this, but add to give me this. When they're only one off like this, it's almost always your this and 1. So negative 10 and 1. Negative 10 times 1 is negative 10. Negative 10 plus 1 is negative 9. Bust apart that b term with those. So this becomes 5x squared minus 10x plus 1x minus 2. So here, once again, that 10 and that 1, negative 10 and 1. Put parentheses around my first two terms and my second two terms. Factor out what's common. So 5 and 10 both have 5 in common. X squared and x both have x in common. That leaves me 5x squared. I factored out 5x. That leaves me just x. Negative 10x, I factored out the 5x. Well, negative 10 divided by 5 is negative 2. The x and the x cancel each other out. Now for this one, it looks like there's nothing common between x and negative 2. But I always have to factor something out. If it looks like there is nothing in common, then it's actually just 1. 1x divided by 1 is just x. Negative 2 divided by 1 is just negative 2. Notice that allowed my parenthesis sets to be perfectly the same. So that's going to be one of mine. And then my outside ones also they combine to create my other factor. And there you have it. So that is factoring quadratic trinomials. Once again, you don't need to use this method here. This is something new that I'm doing. But if it helps you organize your work, go for it. As long as you're doing those steps, you're always looking for what two numbers multiply to give you your a times c and add to give you your b. So these were doing trinomials. The last ones we're going to look at are specific ones that are binomial. So first off, what we're looking here, once again, are quadratic, so x squared, and they are binomial, so there's only two terms. Notice that the second term for each of these is a constant. So it is always going to be x squared, and there can be some number with it or not, and then minus some sort of constant. It could be x squared minus y squared. That's okay because it is something that is squared as well. But this pattern does not hold true if it's x squared minus 9x. So notice here that there's a variable and it's linear. Because in this case, I would actually just factor out the x, and that leaves me with x minus 9. No longer is this guy squared. So make sure that you have factored everything out that you can first. If what you're left with looks like these two that we have, so something squared minus, the minus is really important, something else, then we can do what is known as a difference of squares. When it follows this pattern, notice that it factors to a plus b, a minus b. A represents the square root of your first term. B represents the square root of your second term. So here, if I were to factor this one, the square root of 16 is 4. The square root of x squared is x. So inside of my first factors, or both my factors in the first term, and write 4x. And one of these there's going to be a plus sign. The next one there's going to be a subtraction sign. Does not matter which one comes first. And then the square root of 9 is 3. And there you have it. This one looks a little different because for most of us we're going to say, hey, 7 isn't a perfect square. But I know that I can take the square root of 7. So the square root of x squared is x. Because it's subtraction, I know I can follow this with a plus and minus. And then the square root of 7 is just the square root of 7. Now that looks a little ugly, but that is actually how you would factor this all the way down. These would be considered irrational factors because they have an irrational number, but that is okay. They would still be considered linear, and they're real because there's no imaginary numbers in them. So that is another common way that we end up factoring quadratics. And this is if it's a binomial, this is how we can tackle it. If it was a plus sign, it wouldn't be factorable with real numbers. And then if it's a trinomial, this is our other method.